Hi students, this is my third lecture on industrial management of Unit 5, which is project management. I have discussed about network fundamentals, activity, events and network in lecture 2. Today I will discuss about network representation. As you can see here, this is our slide. We will discuss this slide today. So, network representation. First point is the head of an arrow represents the start of the activity and tail of the arrow represents its end. First point you can see here, head of the arrow, we represent an activity by arrow, and this circle represents events. This is representing an activity A. So head of the arrow represents finishing, represents the start of the activity, and tail of the arrow represents its end. Okay, and then activity description and its estimated completion time are written along the arrow like this. If this is the arrow, we represent here time like 15 days, so we represent duration on the arrows. All those activities which must be completed before the start of the activity under consideration are called its predecessor activities. Those activities which must be completed before the starting of the another activity. For example, like see here, we have activity A is here, then we have activity B. So A is the predecessor activity of B. Before starting B, we need to finish A. So A is coming before B. B will start only after completing this A activity. So this is second point. Third point, and then all those activities which have to follow the activity under consultation are called its successor. And like this is A and this is B. So B is in this is B. So B is called as the successor of A. A and B are representing here activities. An activity which is used to maintain the predefined precedence relationship only during the construction of activity is called as dummy activity. See, this dummy activity term is very important. You must know dummy activity is nothing. It is a activity which is used in project management where we make network representation or we precedence relationship. Then dummy activity is used to logically satisfy the precedence relationship. We just use it to satisfy logically the relationship. It do not consume any time or resource. So dummy activity is represented by a dotted arrow and does not consume any resource and any time. It does not consume any time or resource. It is represented by a dotted line. It will be represented by a dotted arrow. Okay, so an activity which is used to maintain the predefined precedence relationship only during the construction of a network is called dummy activity. The next point, an unbroken chain of activities between any two events is called a path. Like I can show you here. So this is activity A, this is B, this is C, this is D, this is E. So here we have two paths, A, B and C. A, B, C, this is one path, and another D and E is another path. So this all A, B, C, D, E all are activities of the project, but having different paths. It is going, D is following another path and A, B, C is having another path. So this is a network diagram of a project which has 5 activities. Okay, then rules for drawing network diagram. First rule is each activity is represented by one end and only one arrow in the network. No one activity can have two arrows, or it will be represented only by one arrow. We do not, like this is A, so this means that this activity is represented by only one arrow. We will not make another arrow for this activity. We will have only one arrow for one activity. Then second point is no two activity can be identified by the same end events. For example, see here, I have shown you this here. Second point is shown here. They see what is this is. This is activity A, and then we have activity B, and then activity C. So this concept is wrong, because what I have done, B and C both have same starting and finishing nodes. So this is wrong. We do not have this kind of rule. We do not follow this rule. This is wrong. We do not. We have a rule which is violating this thing. So we are not following this. Okay. So this is correct. This relationship is correct. How? Because both B and C have same starting point, but both of them have different finishing point. So this is correct. So here we have used dummy activity to satisfy the precedence relationship. As I have told you in the second point, no two activities can be identified by the same end events. They cannot have same end events. You can see here both have same ends. They are starting from this point and then starting from here, then finishing at here. So both of them have same starting and end point. So this is not correct. This we do not use it, and this is wrong. We have a rule which says that no two activities can have same ends and nodes. To satisfy this relationship, here we have used dummy activity to satisfy our precedence relationship. And next slide, here we have third point. In third point, precedence relationship amongst all activities must always be maintained. So we have to maintain precedence relationship, as I have told you in point 1 and point 2. Dummy activities can be used to maintain precedence relationship only when actually required. In last case, in second point, in the example I have shown you, here also we are using dummy activity, because if we do not use dummy activity, then both B and C will have same endpoint, and it is used only when required. We do not use unnecessarily so many dummy activities. It will make our precedence relationship illogical. So we use dummy activities only when it is required. Then fifth point is looping among the activities must be avoided. For example, you can see here we have here a loop PDC. This is wrong. We do not use looping. We do not follow looping, and this is right. Next one is it is right. Why? B and D are moving forward and C is also moving forward, so there is no loop here, so it is correct. Then we have dummy activity. What is dummy activity? An imaginary activity. As I have told you earlier also, dummy activity is an activity which is an imaginary activity which do not consume any resource and time. An imaginary activity which does not consume any resource time is called dummy activity. Okay. Dummy activity are simply used to represent a connection between events in order to maintain a logic in the network. See, it is only used to maintain logic, to follow the rules of precedence relationship. It is only used to maintain a logical sequence of the network. Use of dummy activity here. Two activities starting from a tail event must not have a same end event. I have told you earlier also. No two activities can have same tail and starting point and end point. To ensure this is absolutely necessary to introduce a dummy activity. So to avoid this issue, we use dummy activity concept to maintain logical relationship. Okay, so dummy activity is nothing but it is an imaginary activity which do not consume any time and resource. So we will go to next slide. In this slide I have solved the example. I have shown you an example how to make a network diagram. Consider the project given in table and construct a network diagram. We have 6 activities: activity A, B, C, D, E and F, and there is a description about the activity. Purchase of land. Activity A is purchasing of a land. Activity B is preparation of building plan, then level and clean the land, then registration and get approval, construct the building and painting the building. So these are 6 activities, and there is some predecessor, means for example see activity A do not have any predecessor, means it can start without any delay, it can start without following anyone. Okay, you can see here activity A is starting from this node because it do not have any predecessor, so it can start initially, we can start it without from 0 time. Activity B can also be started from 0 time. Here we have 0, means initially our time, let us consider our time is 0, and we will start we can start activity A and B from starting, that is at 0 time. Then we can see that activity C follows activity A. See here, activity C will only start after activity A, and I have shown you here also in network diagram. See, activity C is starting only after activity A. Okay, then see about D, activity D. Activity D depends on both activity A and B. So and I have shown activity D here. It is starting after B, but we need a dummy activity to make a logic complete, to make it proper, to make this precedence relationship accurate. So we are using here dummy activity. Now see, D is starting only after A and B both, so it is also correct. We have made a relationship correctly. Then you can see E is starting after C. See here, this activity E is starting after C, and then final F is starting after D. So this is a network diagram. We have made a precedence relationship from this table, and we were given the activity and their description and predecessor. So it is nothing, we have done nothing, we have just followed a sequence. You need to follow a sequence. Like see, A and B do not have any predecessor, we can start it from 0 time. Then C follows A, C will only start after A, D will only start after A and B, E can only start after C, F can only start after D. So we have made a network diagram. In this network diagram, arrow represents activities and circle represents nodes, starting and finishing time of the activity. Now we have critical path method. In network analysis, we have critical path method. It is a technique we use in project management. So CPM is a mathematics based algorithm for scheduling a set of project activities. CPM is an algorithm for scheduling, for sequencing, for scheduling a set of project activities. See here, we have different activities here. So we use CPM methods to schedule these activities. We have here 6 activities. We can use CPM method to schedule these 6 activities. It is an important tool for the effective project management. Second point is about CPM is it is a tool. It is an important tool. We have so many tools of network analysis like CPM, critical path method. Then we have PERT, and there are so many other methods. But we use generally CPM and PERT. We have 2 methods which we use in network analysis, CPM and PERT. PERT is another tool which are used in project management. Critical path method, and then we have PERT, program evaluation review technique. Commonly used with all forms of projects including construction, software development, product development, engineering and plant maintenance. So CPM technique is used in these fields like projects of construction, software development, project development, engineering and plant maintenance. Any project with interdependent activities can apply this method of scheduling. So we can use it in any project where the completion of different activities are deterministic. We have fixed time for different activities. So where we can use CPM technique, critical path method technique, we can use there where time is because CPM method is deterministic method. Deterministic method means we have certain time, we have fixed time limit given for different activities. So there, wherever we have certain time which is fixed time is given to us, and we know the time of the different activities, then we can apply critical path method in that project. Then next slide we will see some more thing about CPM. Critical path method, point number 1. You can see here, point number 1, the critical path for any network is the longest path through the entire network. So what is critical path? Critical path is the longest path through the entire network. We have a network diagram and we will find out critical path. Critical path is that path which has longest time. Means what does it mean? It means that if we follow that path, then that path will be longest and it will tell us about the completion of the project. Critical path tells us about the duration of the project. Okay, since all activities must be completed to complete the entire project, the length of the critical path is also the shortest time allowable for completion of the project. As if 70 days is the critical path, it is the duration of critical path. So this 70 days tells us that we need at least 70 days to complete the whole activities of the project. Critical path, if the duration of critical path is 70 days, so there can be other paths also in that network analysis. Those paths will have duration less than or equal to 70 days. So it means that this time is the minimum time needed to complete that project. So critical path also tells us about the minimum time required for the completion of the project. If the project is to be completed in that shortest time, all activities on the critical path must be started as soon as possible. As critical path, as the activities which are lying on the, for example, see, if we have like this, A, B, C and D. Okay, and we have another let's see, A, B, C, D, E, F. We have a precedent election. There are so many paths like this, A, B, C, D, C, E, F. There are 6 paths, 3 paths, A, B, C, D, C, E, F. These are 3 paths. Let us assume that C, E, F is a critical path. So all those activities which are lying on C, E, F path is critical activities. If you will delay C activity, then you will delay your project. If you will delay C activity by 1 day, then your project will be delayed by 1 day. So the activities which are lying on critical path, they are also critical activities. So we don't delay those activities which are on the critical path. We try to finish them or complete them as soon as possible. The activities which are lying on critical path are critical activities. We do not delay those activities which are lying on critical path. So these activities are also called critical activities. The activities which do not lie on the critical path is called non-critical activity. Non-critical activities may have some slack. Slack means, what do you mean by slack? Slack means weekend extra time or flexibility. You can say flexibility. You can delay those activities. Slack means the extra time you have so that you can delay those activities. So non-critical activities have some slack, some extra time. You can delay those activities. Slack is the amount of the time by which the start of an activity may be delayed without affecting the overall completion of the project. Slack, what is slack? Slack is the amount of extra time by which the start of an activity may be delayed without affecting the overall completion of the project. So slack is the extra time which we have for non-critical activities so that we can delay those activities if we need it. But a critical activity has zero slack. It is very important. We cannot delay critical activities. We cannot delay critical activities. No delay. We cannot delay critical activities because they do not have slack. They do not have extra time. If you will delay critical activity, then your project will be delayed. Your project duration will increase. So the activities which are lying on critical path are known as critical activities, and we cannot delay activities which are lying on critical path. Okay, they do not have slack, they are critical activities, you cannot delay them, they do not have slack. Okay, so in this slide we have discussed CPM, what are the different points and features of CPM, and we have discussed about critical path and critical activities, non-critical activities, and slack. Slack is the extra time by which you can delay any activities. Okay, so in my next lecture, that is lecture 4, I will discuss one more example and something more about critical path method. Okay, thank you. If you have any doubt, you can directly message me. I will try to solve your issues.